So it's Unit 3, Lesson 8. This is an application piece, the graphical approach to using our calculator for parabolas. So a lot of stuff we kind of talked about throughout the unit. And maybe in hindsight, maybe we want to put this one a little bit maybe earlier so you guys can see the stuff with it. But anyway, using a graph calculator to find the max and min values. Okay, so this is how you find a max or min. So you go through, this is the steps to doing so. Let's just go down here and do one here. Because I won't read it to you. It's a little bit easier if I just do it. So let's go and do this one. Okay, negative 4t squared plus 48t plus 3. Okay, so I'm going to go to my calculator. I'm going to put that in the y1. So I'm going to go negative. Make sure you put a negative, not the minus sign. Sometimes the calculator doesn't take the minus sign. Okay, negative 4x squared, just x for your t. Okay, if you look up here, it does have a t, so saying anything that's a variable. 48t, which is 48x for us in this, and then we're going to go plus 3. Okay, and so we can kind of see that these numbers are pretty big. Like, well, excuse me, 48's pretty big. So when I look at that, I may not be in my view very much, and it's not. So right there, that's my standard view. Now this right here is a skill when it comes to your SATs or when it comes to your diplomas the next year. It's very helpful because people are like, oh, I don't know what to do. You got to change your window. Okay, now let's just think about this just for a second. You see this line here, right? Okay, we should know this parabola is what type of parabola? Parabola going up or a parabola coming down? It's a negative 4t, so it's coming down. So it's going to be actually a maximum. It's a hill. And so what I want you to think about is, you see how it's on this left side and then it's over here on the right side? It's doing this. Does that make sense? It's doing that right there. So I don't care about this area. I don't care about this area. This area I do a little bit, but not too much. I really want to make this piece bigger. So that means I want to extend my x, and I want to extend my y. Does that make sense? So I'm going to go here to Window. I'm sorry if you know what I'm talking about already. I'm going to make my min smaller. Make it negative 2, not negative 10. I don't need that much. I'm going to make my max, let's go 150. You can change your scale too, which shrinks it down for you if you want. So like if you don't want to go by 1s, you can make it go by 5s. You can make it go by 10s if you want. It's up to you. I'll just do 5. And this may not be good. I'm just guesstimating right now. My y min, let's just keep that negative 10. And then our y max, oh, my x max, sorry. I don't want my x max 150. I want my x max like, let's just go 50. Let's see here. Yeah, I'm just going to go 20. And I'm going to go by 2s. Okay, my y max, I want to be 150, sorry.
Here it is, Lucas. Look at that.
Okay, and I'm going to go my y scale by 5. Have competition over there?
Actually, yeah.
Okay, here, let's see what this looks like. All right, there we go. That's pretty good. Okay, so I see the whole parabola. That's the point. Okay, I see the whole parabola. That's the point. Okay, so now here's the steps to find the maximum value. Okay, is everybody with me? Okay, here, I'll pause the video just so we can all be on the same page with the calculator. And here we go. Here's the steps. So this is a maximum. So we're going to second trace maximum, number 4. And it says left bound. I want to be the left side of the hill. Right now my cursor's on the right side. So I need to arrow over to the left side of the hill. Just anywhere on the left, as long as it's over the hill. So right there, maybe I'll go a little farther to make sure. I'm definitely on the left here. Yeah, you'll round that, but we'll get to that in a second. We'll go all the way over. Get the right side. Enter. And now we get somewhere close to the top and we hit enter. So it does say 5.99993. We'll just take that as 6. Sometimes the calculator tries to overly get like exact and almost doesn't. So that, to me, that right there, if you see something like that, that's a 6. Okay, that's a 6 to us. So 6, 147. So what's the max value though? Okay, what's the max value? Rob, what's the max value?
We just had it, Lucas.
147. Good. Okay. So 147 is the max to the top of the hill. It happens at 6 seconds. So see how we're all putting the application together? Okay, so let's go down to the questions here. So it says, use graph calculator to answer the following. Sketch the relevant part of the problem on the grid. So we'll sketch this now. Oh, had the eraser on. Okay, so it goes like that. We figured this out to be 6/147. We'll just write that for now. Sketch the relevant part of the problem. We did that. Find the height at 3 seconds. Okay, so find the height of the projectile at 3 seconds. What can we do for that? Yeah, good, Joel. Table. So we can do the table for that. Anybody want to tell me what that is? 111. Good. Okay, let's go and show people how to do that. Go second. See right here where it says graph? See how it says table? Second table. And then you can go 3 is 111. Remember, your x is your seconds. Your y is your height. Everybody see that now? Okay. All right, so we'll get this stuff put back in here. So again, it looks something like this. This right here is 3/111, so it's 111 meters. Find the maximum height it reached the projectile, which is, we said, 147. How many seconds after its launch is it the maximum height? It's 6 seconds. What was the height of the projectile at the launch? 3. That's your y-intercept, right? 3 meters. And then F there, the last one says, determine when the projectile hits the ground to the nearest tenth of a second. Okay? A lot of people, when they do this the first time, they try to give me, they say, well, there's 2 answers. But we don't count this one because why? Yeah, and because it's also in the negative time, which we don't count for, right? We're not going back to the future. So let's find this real quick. So I'll get the calculator up for that. Okay, so that's a 0 function. We've used that before. So we go to graph, second trace, number 2, the 0, and we're going to arrow over here. Hit enter, so I'm on the left. Let's get past it.
Did you just put y2 as 0 and
Yeah. Yeah, you can do that if you want. So 12.06, so just over 12 seconds is when it's going to hit the ground. Okay, you put 12.1, it says nearest tenth, so you were correct. Can you use your table for this? No, because your table measures in x's, not y's. So if you go to your table for this, what are you going to use? It's not 3, right? Right, if you go down, you're not going to get a whole number, right? It's between 12 and 13.
Could the Phantom prep team
You
for
could.
the cafeteria?
You could try to like put a decimal or change your table, excuse me. But all right, so that's the first one. That's it for that one. We'll go on to the second one here. Okay. So just this example, and then we're done, guys. This example, we're done. Let's cut the side chatter a bit. Let's cut the side chatter. I'm glad you guys are in a good mood today. That's great. Okay. All right. So here's the problem. Let's see what it's saying. So we got last season, a struggling hockey club only had 7,200 season ticket holders. The owner of the hockey club has decided to raise the price of a package of season tickets for the new season to generate more revenue. The existing cost of package was $1,400 for season tickets. Before raising the price of a package of season tickets, he hired a market research company to gather data on the proposed increase. The research company reported that for every $25 increase, he would lose 100 people. Okay, wouldn't renew their tickets. Okay, if the price increase is to be a multiple of 25, use the following procedure to determine what price would maximize the revenue from the season tickets. Okay, so we got a lot of stuff going on here. Okay, but we have to develop our equation. So first thing I'm going to say is, in order to figure out your revenue, let's just talk in general. Revenue equals what? So that's the money that you bring in. Not expenses. You're thinking profit. So revenue is simply what? What's that? Good. Money that you get it, but yeah, so revenue is, that's the definition of revenue is the money that you're bringing in. But how do you bring in money? What are you selling, or what? How do you mathematically describe that?
Jim, your clock changed.
So in order to bring in money, you have to have a what? Product. So number of products, right? So number of sales times what? Price. Right? So what you're charging times how many people buy is your revenue. Okay? We'll get to the 25 part in a second. Yeah. Okay? So in terms of that's our revenue. And now to what Noel was saying, let's break that even further to our cost. So what's our cost equation? So this is what you were saying. The 25 is involved. So what was the initial price? 1,400 plus 25x. So that stands for the initial price plus what we increase, 25x. And 25 is set. Yeah. What's that? Not quite. We're going to do the minus 100 piece in a second. The minus 100 piece comes to, so this is good. Okay. The cost is the price, right? That's what we're going to charge. And what Joel's talking about, where's the minus 100 come? That affects the sales, right? So our sales number is affected by what we raise. So it's the same x. So if I raise this by 2, that means I'm losing 200 people. Do we understand that? So then my people, so number of people is going to be the 7,200, and then what Joel said, minus 100x though. Does that make sense? So we have the cost, which is 1,400 plus the $25 raises. For every x of raise, we lose 100 people to the 7,200. And those two numbers multiplied will give us our revenue, right? Number of people times the money we're charging. Everybody with me? Okay. So now if you're saying, well, where's the quadratic? We have to multiply these, right? I'm going to come into the graph a little bit here. So we just need to FOIL this out. Going to FOIL that out to get an equation because you're going to get that x squared. Okay? You could leave it if you wanted, actually. You could leave it like this and put in your calculator. That's fine. But I do want you to notice is, see how you're going to go plus 25x times negative 100x? So it's going to be a negative x squared. So it's going to be that downward. So we're finding a max revenue. Okay? Let's go ahead and just put in just like this. We don't have to multiply that out. Not these two, because these two are the same equation. Right, we want to put these together. Okay, that's important. Okay, so let's go ahead and do that here. So let's put these in together. Again, we won't have to multiply them out. Let's just go 1,400, plus 25x times 7,200 minus 100x. So I'm putting that in my calculator right now. Now this one's going to be very difficult to see because it's really big numbers. Right. Okay, check your signs. Okay, so window, we're going to have to go quite a bit bigger. So the x isn't going to be that big because we're not going to, why is x not going to be that big? Because we're not going to increase it like by 20 times, right? Because that's going to lose a lot of people. That'll lose like 2,000 people. Okay, so we'll stay with 20, but I wouldn't go any bigger. Okay, and then let's go ahead and take, I don't know, we're going to have to go in the thousands. So our y max, so our y represents our revenue. So our revenue right now is 7,200 times, yeah, we're going to have to go like in the 100,000s. Let's do 100,000. Is it 10 million? Okay, let's go, okay, so if it's 10 million, then we want to go, let's go 20 million then. So we got 20, I want 6 zeros, I got 4, so I need 2 more zeros here. Still not big enough? What do you want to go to? Let's go by thousands. This is getting fun, you mean? Yes. Yeah, see, we're still not big enough, so that does mean we're not getting it big enough of the arch, so we're barely seeing a turn yet. Okay, you can do zoom fit, and like I said, zoom fit sometimes does, let's just try that. We can try zoom fit, but sometimes zoom fit, zoom fit's right here, it's numbered like 0. Okay, so it worked out good that time actually. Okay, so for the really big, let's see what the window is. Yeah, interesting. So, what is it at? The min's even down. Oh, see, it doesn't even give us that. It keeps going, so. We had the right scale, though. We had 1,000 scale, so that's good. All right, so there it is. That's the point. We're trying to find the max, so we got to do the max part now. 4. There you go. Do it. Oh, no. I have to restart. Okay. Okay, on the right side, hit enter. Close to the top. Okay, so 8. So in order to maximize their idea, they need to raise it 8 times. So that means 8 times 25, they want to raise it $200. Okay, so they want to raise their tickets from the, what was it, 1,400 to 1,600, and that will maximize their revenue based on the results that they got from the data people. Okay, so that's what we just figured out. So let's go and put that all into words here. So we already had the picture, so I'm not going to draw that for now. Use the results to generate expression of the revenue obtained. We did that, so the revenue equals the 1,400 plus 25x times 7,200 minus 100x. Okay, determine the price of the package to generate the max revenue. We did that. The price would be it'd be 1,400 plus 200, so $1,600. How many season ticket holder would there be if this plan was implemented? So there was 7,200, right? And if we raise it 8 times, we lose how many people? 800. So 7,200 minus 800 is, we now have 6,400 people that buy season tickets. 200 is because you know how we got 8, right? So 25x, so 25 times 8 is 200. 800 from, because 7,200 minus 8 times 100 is 800. Yep. Yep. We're both of you just missed. We put 8 here, right? Okay. How much more revenue would be generated if the plan in C was implemented? So you want to figure out how much money they'd make this time, like if they didn't change, versus how much they're gaining by changing it. So if you do that, okay, I'll move this up. This is our last piece here. Okay, so the original, so I'll just put original plan, original revenue, OR. The original revenue would be 1,400 times 7,200, right? That one is 10 mil, 80, 10,080,000. One more zero there. Okay, if we make the changes to the new revenue, we would get 1,600 times 6,400. That would give us 10,240,000. And so we subtract those to figure out what the difference would be. You would make, your revenue would increase by 160,000, which that's a pretty good chunk. Yeah, 160,000, how much money did you make by making that change? Okay? All right, perfect. We'll stop there.